session, we will try to cover the second part of module 3, reading and writing files. So let's first understand what are files and what are file paths, right? So this, what we see on the right hand side is the files or the hierarchy of folders. So this is under C drive, you have a folder called as users. As suppose under C directory, you have the users folder. Under that, I have AI folder. Under that documents, under that, I have a document called as project.dx. So every file here will have two properties. One is the file name and second one is the path. The path would actually tell the location of the file. So project.dx here is actually a Word document, which is under these respective hierarchy of folders, which we also call as directories. So the folders can contain, or these are nothing but folders or directories. It can contain another folder or it can contain a document, as we see here. So in this entire session, we will be actually seeing how we can, using Python programming, how we can actually read and write the files, right? So first, let's try to understand the way the file paths are actually handled. So in Windows, the file paths are actually written using backslashes as a separator. Whereas in Mac OS and Linux operating systems, the path separator is a /. Now we want our programs to work on all kinds of operating systems, right? So this can be easily done in our Python script by using the path function, which is available in the pathlib module. Okay, so first you have to, from the pathlib, we have to import the path module. And suppose I mention these are the different strings that I'm given here, right? So basically what is this path function will do is it will return a string with a file path using the correct separator. So when I give something like this, we'll go to the Jupyter notebook and see what happens. See, I have imported the path module, and path function, to the path function, I'm giving these three different strings. And when I execute this, you can see that it is generating a path, right? And fortunately, as I told you, though we have backslash separating the folders in Windows, whereas / separating the folders in Mac OS or Linux operating system, it can be easily handled in our Python script by just using this path function under the pathlib module. Okay, so this will take care of it. Though here you can see that the separation is actually /, it will still work for Windows. So you can see that this path function is returning a path, right? Using all these different strings using the separator, which is actually a /, which will work for Windows as well as for Linux. Now, if I want to have a text of this path, right? Suppose for my program, I want to have a text of this path. Then what I have to do is just put str for that, right? So for this path function, you precede it with a str, and what will happen? It will return a string. Okay, so basically the path can be converted into a string by typecasting that with a str. Now the str function basically is used here to get a simple text string of this path. And as you can see here, when you got the text string of your path, there are two slashes, right? You have two slashes. The backslashes are actually doubled up. And why it is done is because it shouldn't be treated as an escape character. So for that reason, you're getting two backslashes. Okay, when you're working with strings, if you just have one backslash here, it can be treated as a escape character, which we have discussed in the last class in string manipulation. So to avoid that, two backslashes are automatically generated by the str function. Okay, and remember this, though Windows are using backslashes and Linux is using / and path function is actually generating a /, but still path function will ensure that this will work for both Windows, Mac OS or any kind of operating system. Now, if you want to join the paths, suppose in my program I will have two different paths and I want to join them, then I can usually do it using this / operator, which we normally use for division, right? So this is operator overloading. I can use an operator for different situations for different functionalities. Now this operator, when I use it, I can also use it for joining the paths. So how do you do it is, see, this is the path I have, right? I have a path here called as C drive, and one more path I'm mentioning here, Python. And here I have maintained a slash. So what is the slash operator is doing is it is joining these two paths. It's joining this path with this path. Let's go to the Jupyter notebook and see how it works. See, this is one path, C drive is one path, and this is another path. So I am joining these two things by using this, as well as this is another path, right? This is one path, this is another path, this is another path. I'm trying to combine all of this. How am I doing? By using this slash operator, which will actually join the path, and the output of this, you can see that it has generated a path like this. So basically this is used for joining the paths, but you have to do it in the path function. Now, if suppose I want to find out what is a current working directory, then how do I find out is using CWD command. So under path function, you have to call the CWD function. Under path module, you have to call the CWD function. So first import the path. First you have to say from pathlib import path, right? Then you have to say path.cw. So it will give us the current working directory. So let's go here to this. Okay, so let me do that here. First, you have to import the path, and then you have say path.cwd. So when you do that, what happens is, okay, the P has to be a capital letter. See, the current working directory of my system is this. So CWD will give you a current working directory. Now suppose I want to change my path, right? Then you just use chdir. Chdir stands for change directory, but this is under the OS module. So first you have to import OS and then say os.chdir. So then what it will do is it can change your directory, right? You can change your directory, current working directory. So how you do it is, again you have to import the OS module. So under that you have to say os.chw, dir change directory. Now here you mention what path you want to give. So let's say I just give something like the C colon slash I want to change that directly. Let me say something which is existing. Under C I will take Vaani 1. So what happened now? If I just call the path.cwd, I should be able to see that the working directory has been changed. Okay, before my current working directory was this. I want to change my current working directory. So for that I use the change directory command, which is under the function, which is under the OS module. So after I change that, you first change it to a directory which is existing in your system. Otherwise it will give you an error. Suppose I change this to something which is not existing. I think it's there. So then it will give you an error, right? Mention a directory which is already there. So when you do that, then if you check your current working directory, you can see that the working directory has changed. Okay. So let me change back to the previous one, because I'm keeping all my files under that. I'll change it back. Okay, now, so that was about finding out the current working directory and for changing the directory. Okay, so now let's see another function. So this is about it, right? Now, what is this doing? This code is actually telling us how we can join the names from a list of file names, right? I have a list of file names here, accounts.txt, details.csv, invite.dx. Now I am going to join these into an existing file. So under C, I have a folder called as users. Under that, I have a folder called as AI. So I want to mention, join the names of all these different files like this: account.txt, details.csv, invite.dx, docdx. So I can put it in a for loop, right? And in the for loop, the first path would be fixed. That would be C users AI, which is actually fixed. And the last part is only what we want to change. So that I will give under file name. And that file name, under that, it will be, the file name will now be looping through this my files list, where I have these list of files. So, and as I told you, it's always good to use forward slashes in your Python code. So remember, use forward slashes in your Python code, though you're working in Windows operating system or whichever. It's a good idea to use forward slashes, okay? So that it works on all the operating systems. So now let's do that. So this code, what we are doing is under my files, I'm having a list of all the files, a text file, a CSV file, and a docx. Now I'm going to loop through these files, right, and ensure that these programs, these documents are under this folder. So when I execute this, you can see that under C, under users, under AI, I have these files. So basically, this is a code to join the names from a list of file names to the end of a folder's name. Now, coming to the home directory, suppose you want to find the home directory. Now, all users will have a folder for their own files on the computer called as home directory or home folder. So, how do you find your home folder? Just very easy. Under path, you have the home function which you have to call. See, when I call that in my notebook, right? So, you can see that this is my home directory. Under C, under users, I have my name. Basically, this is my home directory. Okay, so if you want to find your home directory, just use this command. So home directories are located in a place like normally under C, under your users, under normally your name, it will be present. Now, this is very important. It's very important that you try to understand the difference between absolute path and relative path. Now, remember, absolute path will always begin with a root folder. Okay, and relative path is related to the program's current working directly. So it's very clear. Absolute path comes from the root folder. So for example, I have here spam text. Now the absolute path will start for it from the root folder. So like this here. See spam text, the absolute path will start from C drive, under that bacon, under that fizz, under that spam, like that. So it is directly from the root folder. Root folder here is C. But relative path is basically from where you are, right? So if I want to open spam.txt, right? Suppose I am under the folder X, then relative path is with respect to the folder X. So basically it is related to where you are exactly now. Okay, and there are also two types of things you might observe here, dot and double dot. So you can see here there is a dot here and there is a double dot here. Now what's the difference is, dot when you see, or a single period for a folder name, it is basically a shorthand for saying this directory. It's a shorthand for this directory. And two periods or two dot dot means parent folder. Okay, so if you have a single dot, it means this directory, the present directory where we are actually now, or basically the current working directory. Dot dot means the parent folder, the parent folder. For example, if I am now in spam.txt, if I say dot, right? So basically it will be this directory. So basically where I am under X, I am under spam.txt. If I say dot dot, what is the parent folder of this X? So that's the difference. So let's open the Jupyter notebook and observe. Let's work on this absolute path and relative path. Okay. So here. Now suppose, how do you handle this? Like what is the CWD will actually give me the current working directory. Now, how do you know that this is an absolute path, this path is a relative path, right? Now, absolute path means it should start from the root folder. Relative path means the current folder. But how do you know this path is an absolute folder or a relative folder? For that, you have a function called as is absolute and is relative. Okay, so is absolute will, what it will do is, it will tell, right, is the current folder a absolute path, is the current path an absolute path. Okay, so is absolute method will return a true if it represents an absolute path, or it will return a false if it is a relative path. Suppose you see here, I've got my current working directory as C, under that under Windows, under that System32. Okay, now for this path, I can check. I want to check whether I'll ask you a question. Is it an absolute path or a relative path? If it's an absolute path, means it should start from root folder. How do you do that in the Python script? Just put dot is underscore absolute. It is returning a false. So that means this is not an absolute path. It's a relative path. Similarly, if you want to check it's a relative path, just put dot is underscore relative. Okay. Now let's do this in the Jupyter notebook. Let's print the current working directory. We will print everything so that we can find out how it works. Just give a print statement. See, if you are doing this Anaconda terminal, then you don't have to give print. But since I'm working in Jupyter Notebook, I have to give a print to see the output. Okay. Now the first print is actually giving me the current working directory, which is C under that Windows underscore under that system32. Now in the second statement, I am checking, is this a absolute path? It is saying false. So that means it's not an absolute path. Now I've given a path here. Is this a relative path? Right? This is a path, right? It is printing it. So what I am doing here is my current working directory, to that I am joining an other path. Right? That's what I did here. My current working directory is what? C Windows System 32. This is what, as I already told you, it's basically used to join the paths. So to C Windows System 32, I am joining my relative path. Right? You can see here, though I use backslashes here, it is changing it to forward slash. Right? So it is in Python, it is forming a uniform code naming convention. It's always using forward slashes for all the paths, irrespective of whichever operating system. So this is a path I'm getting. Right? Now, if I want to check if this is a relative path, so what you do, just put here print, give the name of the path, and then ask whether it is a absolute path. Okay, is underscore absolute. I think one more is missing. Path. Yeah, there is a quote which is missing here. Put a quote, single quote here. Invalid syntax. Yes. See, I'm checking whether this is an absolute path, and it is saying it is a false. It's not a absolute path. So just very simple. If you want to find out a path is absolute path or relative path, just use is underscore absolute. Now, there's one more thing called as make directory. So you can also make your own directories. How do you make your own directory? Using the command make this function, which is available in the OS module. So first import the module OS, and under that you can see os.makedirs. I'm giving some folders. So what is it going to do is it's going to create folders, right? Under C, it is only creating a folder called as delicious. It's creating another folder called walnut. Under that, I'm creating another folder as waffles. Now, there is another way also of creating a directory, which is called as mkdir. Now, this mkdir function, it is available under the path module. But in the same way, just give path, give the folder name, and under that .makedir. Right? So basically, the difference between this makeDirs and mkdir is makeDirs, you can create as many folders as you want. You can create a hierarchy of folders. Okay, but when you are using mkdir, you can create only one directory at a time. Okay, so remember this. MakeDirs can create a hierarchy of folders. See, I didn't have a folder called delicious. I didn't have walnut in my system. It's going to create everything. But mkdir, what it will do is, under the specified path, whatever I give, under that it will create only one folder. It cannot create a hierarchy of folders. It will just create one. So let's see this in the Jupyter Notebook. See here, right? So I have, what did I say? Under import the OS, under that I'm saying create all these folders. So if I now go back to my C drive, I should be able to see all these folders. Okay, so go to C drive. Under that I should see delicious. Yes, it's created. Walnut, it's created, and waffles is created. Okay, so basically makeDirs created this folder. Now there's one more thing, makedir, right? So under C, users. So let's go back to C, users. Under that, I'm going to my folder, and under that AI, right? So suppose I don't create this AI. I'll just delete this. Okay. So basically what happens is this will create only one directory, only one folder. It will create only one folder at a time, or one directory at a time. Now I'm getting an error. Let's see what is this. Cannot create a file that already exists. It's already existing, right? So let me just give another name here, AI1. See, now it should be created. So when I go to see users, yeah, AI1 is created. Okay, before it was not there, now it's created. So that's the difference. Makedir will just create one, the last one would be created. The last only one directory would be created here. But in makedir, it will create this entire folder. That's the difference. Now, coming to os.path module. See, now os.path module has some useful functions which is related to absolute path and relative path. So let's see some of them. See, there is a function here called as abs path. Now, what is it to do is, what this function will do is, it will return a string of the absolute path of the argument. It will give the absolute path. And there's one more function called as is.apps. As the word itself says, it's going to check whether the path which I'm giving as an argument is a absolute path or not. If it is absolute path, it will return true, otherwise false. There's one more function called as rel path. And under that, I'm going to give two arguments, path and start. So basically what this will do is, it will return a string of the relative path from the start path to the path which is actually mentioned in the argument. So let's see this in the notebook to get a good understanding. So here it is, right? So first what I'm doing is absolute path. So apps path. So basically what is this? Apps path. It will return a string of the absolute path of the argument. So what argument I'm giving here? Nothing I gave. I just gave dot. So basically what did I say? Dot operator means it will give the, it will go up to the root, right? So when I execute, see, for my current working directory is this, and it is giving the absolute path only. This is an absolute path because it is going up to the root folder, which is C drive. The next one, apps path. For this I'm giving a different kind of argument here, right? So basically what is that? Until scripts, right? So here also, starting from the scripts till it will give us the absolute path. Basically apps path will give us the absolute path. I have given scripts here, so it will go up to the root folder and give you the entire path. So if you want to have in your program, you have a folder, and from that folder you want to go up to the, you want the complete path, the entire path until the root folder, go for this function, apps path. See, scripts folder is existing in my system here. See, Windows, under that system 32, under that I have scripts. See, under that I have a scripts folder. It must be there here somewhere, right? So let's give RAS, make it simple, RAS. See, RAS is a folder, right? It is giving me the entire path. See, under that Windows, under the system 32, under RAS. So what is the use of this is, it will give us the absolute path for the folder whichever is mentioned in the argument. And if I just give dot, what will happen? It will give us, if I just give dot, it will give the path from that respective folder, from C, Windows, system 32 it will give. Now is.apps is, it was checking whether it is an absolute path or not. Since I gave here dot, right? So basically what happened is, it is not an absolute path. It's not able to give a complete path for this. But here I said os dot, okay, if you want to visualize how this looks, let's give a print here, right? See, this is the path. See, when I say os dot path, under that apps path, under the this is actually a path which I got here, and this is an absolute path, and therefore it is giving a true here. Okay, now instead of yeah, so basically this is actually returning, is.apps will return whether it is an absolute path or not. That's all. Now coming to the next uh, topic, getting the parts of a file path. Now if you want to get specific parts of your file path, then how can you do it, right? See, this is the path we have. If I want to get access to the root, right, the root folder of this, you just type p.anchor, it will give you C. If you want to access the parent, right, just type p.parent, right? If you want to access the name of the file, right, then you just give p.name. If you want to access the last part, or this which we call it as a stem, then just give p.stem. If you want to access the suffix of this, the last part is pam.text. What is the suffix? The suffix is .txt. If you want to access the drive, this folder, this entire path is in which drive? It is in C drive. So basically what is this doing this? I'm able to get parts of my file. Now there are other things also. See, I have my current working directory. Under my current working directory, suppose this is my current working directory. If I say parent 0, complete entire all the parents of this current working directory will come. If I say parents 1, the last part would be left out. The last parent would be left out, only this much will come. If I say parents 2, the last 2 parents would be left out and this much is going to come. If I say parents 3, last 3 would be left out. So like that, I'm able to, the parents attribute will basically, it will start leaving one ancestor from your complete file. Okay, so let's see this in the Jupyter notebook. See, this is my path. Okay, I have a path something like this. P.anchor would give what? The root. The root is C. What is the parent? What is the parent of this spam.txt? C uses AI. What is the name of the file? You just give p.name. If you want to access only the name of the file, I don't want the prefix that is .txt or what, then you just give p.stem. If I want the suffix, I want this txt, then just give p.suffix. If I want to know which drive it is there, then give p.drive. So therefore, I'm able to get the different parts of the files from the file path. Now, coming to the next topic, if I want to find the file size and the folder contents, so I can use a function under os.path.getSize. Give the name of the file. You can get the size of the calculator. Calc.exe is nothing but a calculator which is there in every system, right? So what is the size of that? It will give us. Okay, and you can also use the .listdir to basically list all the directories under your current working directory. So let's go to the see here, os.path.getSize, and I want to find the size of my calculator. And what is the answer it gave? It gave the answer as, let's execute. Okay, let me first remove this. So this is the size of the calculator. The size of the calculator is 27,648. Now, under C Windows System 32, there are so many folders, right? So if I want to list all the directories under this, so just use a function listdir and give the path. See, so many directories are there. It is going to list it. Fine. So this is a command for finding the directories, and this is a command for getting the size of the file or a folder. Now, modifying a list of files using glob patterns. Now, what is glob? Glob is actually a method for listing the contents of a folder according to a glob pattern. Now, what are glob patterns? Glob patterns are like simplified form of regular expressions. Okay, so just to quickly understand here, suppose I have a path something like this. Under D, I have a file called as YT online course. Now, if I say p.glob asterisk, see what is it doing is it's generating an object that I will need to pass to my list function. Okay, so this p.glob asterisk is generating an object which I will pass it to the list function, and in order to easily view it in the interactive shell. So basically what it will do is it will list all the text files, right? This is something like I can it will list all the text files because I mentioned here star.txt, right? It will basically list all the text files which are under this path. Okay, and instead of say star.txt, suppose I give an question mark. Suppose in my folder I have project1.docx, project2.docx, project3.docx. So instead of saying 1, 2, 3, in place of that, if I give a question mark, it will list all the files which are documents which are starting with project. See, project 1, project 2 is there. I can also combine the asterisk and the question mark. Okay, so if how do I combine it? Under p.glob, you give asterisk, you give a dot, you give a question mark, you give x, you give a question mark. So then what happened is it's just listing of all the files, like comprising of the projects and everything, right? So basically this expression will return files with any name and any 3-character extension where the middle character is x. Because what I've given here is question mark x question mark. So basically it will give list of all the files where the middle character is x. Okay, so let's see this in the notebook. Okay, see, this is the path, right? Let's go to this path to understand better. See, under D, YT online course. So these are the directories I have in my system, right? So when I execute this, right, so what is this Glob doing? As I told you, Glob will actually return the generator object, and that generating object I am passing it to a list. So basically it's going to list of all the text files, right? Let me give a print to all to visualize. See, the first print is basically listing all the text files, because I for Glob I said I want to only see the text files. The text files under these folders are how many I have text files. I have just one text file, that is test. So it is displaying that. And when I said project, under that I have just one two projects, right? .docx. Therefore it's displaying project 1 .docx and project 2 .docx. And here what I have done, I have an x right in between two question marks. So basically I will be getting a document. C, that is only this, a document where you have a x in between, asterisk dot question mark x question mark. So basically asterisk means here it doesn't matter whatever file name is, dot x is there. So basically there is only one file by this format, so that is why it is getting displayed. Okay, so therefore what is Glob doing is basically the list. It's used for listing the contents of a folder, but according to the pattern or the Glob pattern which we are giving it in the argument of the p.glob command. Okay, try this in your system, then you can get a when you get a hands-on you can understand it much better. Now there's one more function for checking the path validity, whether the path we are giving exists or not, right? So p.exists will return a true if the path exists, or else it will return a false. P.is file will return true if the path exists and is it a file, otherwise it will return a false. P.is director will return a true if the path exists and if it is a directory. If it is not a directory or if the path doesn't exist, it will return a false. So let's see this command. Yeah, I have a directory here called as C Windows, right? I'm also creating a directory which actually does not exist. Okay, now when I say calc file, to calc file, I am passing this path which actually exists, right? So when I say vendor.exists, it actually exists. Since this directory exists, see, under C I have Windows, so it is returning a true. Now I'm also checking vendor is a directory. Yes, it is a directory, right? Windows is a directory and therefore it is returning a true. Not existed, not exist is this path, right? It is actually not existing. I don't have a folder like this and therefore it is returning a false. Calc file is actually our calculator file. Is it a file? Yes, calculator.exe is actually a file and therefore it's returning a true. I'm checking for the same thing. Is it a directory? No, calc.exe is not a directory. Therefore, it's returning a false. That's all, simple, right? So basically, this is used for checking the path validity as well as checking whether it's a file or it's a directory. Try this. Only when you try it works. Next, how do you read and write into a file, right? So for that, just let's first you have to under pathlib you have to import the path module, and under that give the name of the text, right? And suppose this is the text spam.text. Now under that, how do you write? Using the write underscore text. So suppose I want to write this into my text, it would be written, and after returning you can see there's a value 13 which is written. So basically 13 is a number of characters in which I am actually writing into my file. So spam.text, under a text file I have written this content and it is returning 13, basically the number of characters which I have actually written using this write underscore text function. And how do you read it? Read underscore text. So very easy. Read underscore text method is used for returning a string. It's for basically reading the contents of a text file. Write underscore text method is used for creating a text file and writing into it. So normally when you are to read and write into a file, three steps are followed. First, you have to open the file. See, now normally when you want to work on a Word document, what do? You first open the document. Then you write something into it, then you close it, right? The same sequence is followed here. First call the open function, then you call the read and write method, then you close method. Okay, so what does the open function do? Is open function, when you say, under that you have to tell what is the direct folder, right? Where do I want to create my or open my file? So this is basically the path and this is the file name. Or you can also give the path directory as a series of path, right? It's in the form of you can also give it like a string. So under C, under users, under your folder, whichever, this is a file I want to open. That's all, simple. Next, you want to read the contents of a file. So I have already opened the file and put it into hello file, right? So now under hello file, you call the function read. Now what will this function do is it will read all the contents of the file and put it into this variable called as hello content. So when you display that, you can see the file is actually containing just hello world, and that is displayed. Now, if you want to write into a file, how do you do it is, you can write it in using two modes, write mode or append mode. Okay. Now, see here. Here there's a series. This complete series of reading and writing is there in this document, in this slide here. First, I am printing my current working directory. Okay. Next, I'm calling the open function. Under open function, I'm giving the name of the file and I'm giving the argument as W. So I've opened the file and I want to write. That's why I've given the argument as W. So what I'm writing now, so under sample file dot write, you write whatever you want to write, no, that you can put here as a string. Next, after writing is done, ensure that you close it. Okay, so close it. Now one more file I want to open. Suppose, let's say I want to open the same file. So hello1.txt. Now already something is written into it, right? Hello world again. So and to that I want to write something else. I don't want to overwrite. I want to continue. So that is why you have to keep the mode as A. That means append. Okay, so in open function you have two modes, write mode, append mode. Write mode means if nothing is there, it will start writing. If already something is there and again you write, it will overwrite. So if you don't want to overwrite, do append. Just write A here. So now again close it. And again when you open this file and you want to read the contents of the file, you call the dot read function and put it into a variable. And then ensure after opening, after writing, after reading, at the end always give a close command. Okay, so now let's see this in the Jupyter notebook. See what I'm doing here is I'm going to have a text called spam.txt to which I'm going to write this. So just execute. And since why did this get displayed? Because I said read the text. Now this series will give us the entire series. First you have to, normally what we do is we have to call the open function. First let's see which path, right? So when I execute this, under this path, path.home, let's go to C users under this folder. Let me go to this folder under C, under users. Okay, let me copy paste. Okay, so under this I want to create a text called as hello. Now let's see, it's already there, right? Already it is there. There is something written here, a hello world. Let it be there. Let me first close it. Now what I'm doing under that, I am saying under this folder C users Vaani, I want to join hello.txt. So basically the path is now completely C users my name hello.txt. Right, and now I'm saying open command, I want to open this file. So now the file got opened. Now I want to read it. Now already there was something there, right? Some hello world was there. That would be read and that would be displayed here. Let's see how it works. See, already there was hello text. Already there I had given a content hello word and that is read. Now that was very easy. I just had single line. Now suppose I want to have multiple lines. I want to have a big text into my text. Then what do you do is let's say I have one more file here called as sonnet, right? And under that I have a text called as, see, I'm trying to read a file, right? I'm trying to read a file which is having some multiple files. So that also works, but only difference is instead of using read function, I have to use a read lines function. That's the difference. Okay, suppose I have a text which is having multiple lines and I want to read it. Don't just use read function. If you just read function, it will not read because it will give us some error. See, if I just use read function here, what happens is it will not read it correctly. See, the entire thing slash and it is not reading it correctly. But instead of that, if I use read lines, see, it is reading it in a correct format, and basically it will be in a form of a list. It will get a list of strings. So read lines function will get a list of string values from the file. Okay, so if you want to read a text file which is having multiple lines, use read lines function. Now This is basically the entire thing for reading and writing. If you want to read and write into a files, first open the file, right? Put it in the write mode. Now already hello1.txt. Okay, there's one more file called as hello. Okay, let's hello1.txt I want to create, and there I want to write hello world again. I want to append Python program into it. I want to open it. I want to read it, and then I want to close it. Let's execute this. Now what happened? Let's go and see. Is there a file name called hello1? So let's search under C users. So what's the name of the path? C users, yes. .txt. See, under this folder, you can see that a new file got created. Hello world again, Python programming. Okay. See, if the file is not existing, it will create it and it will start writing. So that was about how you can read the contents of a file and how you can write the contents into a file. Now let's go into the shelve module. Now shelve module basically is used for saving variables in your Python programs into binary shelve files, right? So first you have to import the shell module. Under that shelve, you open the file name. Now let's see here, I have a list called as cats. Now that I want to write it into this document, my data. So how do you do it? Is shelf file. Under that cats I have to write it. So basically this is like a dictionary, right? So what you have to do is first import the shell module, then you call the shelf.open function, pass it the file name, and then store the returned shelf value into a variable called as shelf file. Now you can make changes to your shelf value as if it was a dictionary, which we have studied already. Like it will have a key, it will have a value. And when you're done, so basically what we are doing into this file is we are writing into this shelf file as if it was a dictionary. And then after writing, you have to just close it like we normally do it in a other file operations. Okay, so this is another thing. I'd say shelf.open, right? And you can see the type. What is the type of the shelf file? And you can see what is the shelf, what is the cats, right? Cats is basically the key value. Under that, the values are Sophie, Puka, and Simon, right? So basically, this is a dictionary, right? Cats is equal to is going to have all these values. So that I'm writing into this my data. So shelf value will let you save and open features to your program, and basically where is this very useful is if I have to run a program and I want to have some kind of configuration settings, then you can save those settings to a shelf file and then have the program load it from the next time it is running. So that's where it's very useful. And after we execute this, we will see that 3 new files will be created: mydata.back, mydata.dat, and mydata.directory. Now you don't have to worry what is the meaning of it, but shell will do it in the background for you. So let's go to the Jupyter notebook, see how it works. Okay, so first let's learn how we can save variables within the shell module. To save variables within the shell module, first import the shell module, then under shell open the mydata file, right? And what is this? This is just mother list, right? I'm under cats is going to have basically these 3 values. So cats would be taken as a key and these will be the values. So under shelf life, I'm writing this cats. I'm giving this cats value. So basically when I execute this under C, under Windows, under system32, my data file will be created. Now I want to open it, right? So just like dictionary, shelf values will have keys and values methods that will return list like values of the keys and values in the shelf. Since these methods will return list like values, instead of true list, you should pass them to the list function, right? So now you open the my data function and you print what is there. Shelf file dot keys will actually give the key, which is cats. Shelf file dot values, these are the values of the key. And then finally just close. So very similar to other file operations, but the only difference is here under shelf module, we are basically able to work on this like dictionaries where you have keys and values methods. Now the next concept, the last concept here is pprint. Pprint functionality we saw in the first module. Basically it is used for pretty printing. Similarly here we have a module, a function called as pprint.pformat. What this function will do is it will return a text which is formatted and it is easy to read and it is also syntactically correct. Okay, so what is this? First import pprint. Suppose this is the value that I want to write. What is this? Basically it's a list of values, right? So these are the keys and these are the values. Again, there's a key, there's a value, there's a key, there's another value. So I have two tuples here with dictionaries, basically two dictionaries here. Now I want to print it correctly in a correct format. So if I just call pprint.pformat cats, you can see that the output which I'm getting is the string which I'm getting is formatted and it is easy to read. Okay, so let's see this in the notebook. So when you execute this, you can see that the output is coming pretty printed, right? So this is a key, this is a value, this is a key, this is a value. Now, once we have the data in the cats as a string, now it's easy to write it. Now I want to write this into my file. So how do you do it? Similarly, first open the file. I can also write it into a Python file. Okay, so let's say I want to create a Python file called as mycats.py. So first open the file, right? And under that I want to do pretty printing. I want to say cats is equal to, under that I want to have the name of the cats. So when you execute this, right, you can see that let's go to the current working directory of this. So let's say what is the current working directory of this is path.cwd. Right, so under C Windows System 32 a file should be created. What's the name of the file that has to be created? mycats. So let's search for this. Yes, see under C Windows System 32 there is a file called as mycats.py which is created, right, which is going to, basically it's a Python script, right? So basically I've written it into a Python script. Okay, so we can try to open it. Let's see. Yes, it's there. So let's open it, upload. See, this is a file which got printed and got pretty printed. See, so basically what happened here is when I execute this, see this entire file got created for this here. Okay, just by this line of code. So what did I say? Cats is equal to, and here you say you have cats is equal to, and I'm saying yes pprint.pformat /in, right? So basically it is asking pprint.pformat, what is cats? Cats is nothing but this. See the input module. So this code has created this file. Okay. So in short, to just say pprint.pformat function is basically used for having your string formatted and easy to read, and it also has to be syntactically correct Python code, right? So basically pprint.pformat will give you a string that you can write it to a .py file, which is your .python file. We can have a list of directories here, we can have which are basically formatted and written into your Python script. So let's see, there's one more, my cats. Let's see, we'll try to upload that. Under C, under Windows, under System 32. Yes. Upload. See, two files actually I've created in my system. So let's try to open this. Yes, open this. See. So basically this file has actually created mycats.py like this, where basically you had a list of cats, right? That was got printed like this. A Python script got generated, and these are the contents we actually wrote from this one. Okay, so try it in your system, then you get a good hands-on. And this is for the second part. The second part where I created another file through which I got this mycats1.py. So you try it. Once you try this, you get a more hands-on. The more you try, the more you understand. Just by reading, you will not, or seeing the presentation, you cannot understand. You need to try it in your system. Okay, so thank you very much. So this I've tried to cover the complete file systems of module 3 of the syllabus BPLCK in this session. Please get back to me in case of any doubts and go through it, try it on your systems, and please subscribe to our channel. Thank you so much.